Hello, Algebra 2 friends, and today we're going to be starting Module 3, which is all about quadratics, Quadratic, dun, da, da, da. And we are going to be graphing parabolas. This is section 3.1, and following this amazing video, you will also have homework, which will be just exactly like the ones we're going to do. So you're going to have some great notes that you can look back on. First of all, we're going to be graphing the parent function. And a parent function is simply the simplest, most easy quadratic to graph. It has y-axis symmetry, which means that we are going to have a line going right through the middle of it right here that's going to cut it into two equal parts. And it's also going to have a vertex. In this case, the vertex is going to be 0, 0. So let's start there and let's find out why. So here we go. Whenever we plug in 0 into a function, which is what we're about to do here, remember we're going to evaluate, that's the math word, we're going to be evaluating the function f of x when x equals 0. And I've got it highlighted here in orange because not only is it going to be the vertex, it's also going to be where the graph crosses the y-axis, and that is the y-intercept. And we can see it here. All this is a squaring function. So whatever we put in as an input value, we're going to square. So 0 squared is 0. So we do have a point right there at 0, 0, which is on our axis of symmetry. So remember I said the axis of symmetry is a vertical line, and since it is a vertical line, we will name it as such, x equals 0. The vertical line, x equals 0, is our axis of symmetry. Notice that I drew it dashed because it's considered to be an auxiliary line. Therefore, it's technically not part of the graph, but it does help us. It does help us when we're graphing. So let's keep going. We're going to do other evaluations here and plot more points on our parent function. So let's do the positive ones. Remember, all we're doing is squaring. So 1 squared is 1, 2 squared is 4, 3 squared is 9. Let's plot those points. Over 1, up 1. Over 2, up 4. Notice this is not a line. This is going to be a curve. Over 3, up 9. Over 3, up 9. All right, let's plug in the negatives. Remember, this is the squaring function. So when we evaluate, we're just going to be squaring our input values. Negative 1 squared is 1. Negative 2 squared is 4. Negative 3 squared is 9. So back 1, up 1. Back 2, up 4. Back 3, up 9. And I'm also hoping that you're noticing that these points are mirrors or reflections of each other. Why? Because they are over that axis of symmetry. So here is our parent function of all our parabolas. That's what this is called. P-A-R-A-B-O-L-A, parabola. So our vertex is at 0, 0. Our y-intercept is at 0, 0. And notice also our vertex is our absolute minimum point. It's the lowest point. It is the minimum point. So we'll be talking about that again more. Once again, this is the parent function. This is the simplest parabola, the simplest quadratic function that we can graph. So we're going to be going from there. Now, before we do any more, it would be great if everybody got some note cards, which are on my desk or maybe even in your backpack. And let's zoom in on these note cards because these are the things that you have to know. They're also in your note packets, but sometimes writing them on a note card is very helpful, so I suggest you do this. This is the standard form, also known as the quadratic form of a quadratic equation. F of x equals ax squared plus bx plus c. Now, notice I've got them highlighted for you and color coordinated. So here are some things that are always true. If your a value, and remember your a value is your leading coefficient. If your a value is positive, your parabola will open up, just like ours just did. If your a value is negative, your parabola will open down. We'll see that soon. Your axis of symmetry is always going to be a vertical line, and we can find it by simply taking x equals the opposite of the b value divided by 2 times a. This is a formula for finding the axis of symmetry. The y-intercept will always be 0, c. Always, if we're given in standard form or quadratic form. That is always true. Next, we've got the vertex formula. So if we're given a function ax squared plus bx plus c, if we want to know the coordinates of the vertex, remember x, y, that's how coordinates come. It's going to be the opposite of b divided by 2a. Yes, that's exactly what we just saw here, same thing, comma, f of the opposite of b over 2a. So whatever you get for your x coordinate, you are going to plug that back in as an input in order to find the y coordinate. Once again, the vertex will be a minimum if a is 0, or greater than 0. Think about it. We just saw that. If your parabola opens up, your vertex is a minimum. If your a is negative, which means your parabola is going to open down, your vertex won't be a min, it will be a max. So these are 2 note cards that I made up. I suggest that you make note cards as well because this information must be memorized. So let's keep going on your notes, and we're going to move on down to your next example, number 1. It says f of x equals 2x squared plus 4x plus 1. I've got them color coordinated for you, so let's list them right over here, maybe right up here. A equals 2, not 2x squared, just 2. A is the coefficient of the squared term. B equals 4, and C equals 1. So these are the first things that we need to extract from our function, and that will allow us to find the vertex and the axis of symmetry. So here goes. The x coordinate of the axis of symmetry, the vertex, so opposite of b is 4, the opposite of b is negative 4, over 2 times a is 2, we get negative 4 over 4, that is negative 1. So the x coordinate of our vertex is at negative 1. So we can put this in right down here, negative 1. Now, guess what? Our axis of symmetry is also negative 1. X equals negative 1. And I'm going to go ahead and put that auxiliary line on my graph. So x equals negative 1. There it is. Remember, it's dashed because it is technically not part of the graph. It's just auxiliary. Let's keep going. So now we need to find that y coordinate of our vertex. So what are we going to do? Well, if we look at our formula card, it says f of opposite of b over 2a. So we're going to go to our function, and we are going to evaluate the function for when x equals negative 1. So we'll be inputting negative 1 here and there. So 2 times negative 1 squared plus 4 times negative 1 plus 1. Be sure that's on the screen. So follow order of operations, which means we will square first. -1 squared is 1. 2 times 1 is 2. 4 times -1 is -4 plus 1. So our vertex 2 minus 4 is -2 plus 1 is -1. So the vertex is at -1, -1. So let's plot that point. Back 1, down 1. Now, what was our A value? Our A value is +2, which means our parabola is going to be opening up. Now, the next easiest thing that we can find, and I have it highlighted in orange here, is to let x be 0, and that is going to tell us our y-intercept. So all it is the c value. Every single time, the y-intercept is simply 0, c. Every single time when we are in standard form. So the c value is 1, so our y-intercept is at 0, 1. We can plot that point over 0, up 1. Now, let's plug in one more value for x. We plugged in 0. Let's plug in 1. So find f of 1. So f of 1 is 2 times 1 squared plus 4 times 1 plus 1. So follow order of operations. Square first. 1 squared is 1. 1 times 2 is 2. 4 times 1 is 4. And then plus 1. 2 plus 4 plus 1 is 7. So we've got over 1 up 7. Now, we learned on the first one that we can just use symmetry in order to graph the other side of the parabola. So if we are 1 unit to the right, we also are going to be 1 unit to the left. And if we are 2 units to the right, we will also be 2 units to the left. And 1, 2, 3, 4, 5, that's what we're looking for when we graph a parabola. We want to see 5 points plotted. Here is our parabola. And I forgot about it on the first one, so let's go back and hit it on that first one. What would be the domain of this function? So just a reminder, domain and range sticking around, we're still using that. So what do I see? This graph goes to the left forever, to the right forever, so the domain is all real numbers, -infinity to +infinity. The range of the parent function, it has a minimum value. Remember, the range is all about the y-axis. So this range starts at 0 and then gets bigger. So the parabola that we just did, let's do it again. The domain is easy. It's going to the left forever, and it's going to the right forever. So it's all real numbers. And the range, once again, we have a minimum value. Look at the y-axis. Our minimum value is -1, and then it goes up forever, so our range goes to infinity. So there we go. These are the steps required to graph these parabolas. Let's turn in your notes to the next problem, which says it's number 2. And now we've got an A value that is negative. So let's put right up above A equals -2, B equals 2, C equals 1. Now we've got an A value that's negative. So we know that our parabola is going to open not up, but down. It's going to be opening down. So let's find the vertex. This is using the vertex formula. So the opposite of B, B's underlined with green. If B is 2, the opposite of 2 is -2. And then 2 times A is -2. So we end up with -2 over -4. And that is 1/2. That is 1/2. Yes, ladies and gentlemen, fractions are our friends. So we are going to have a vertex that has its x coordinate at 1/2. I'll also put it right here. And the axis of symmetry is also going to be at 1/2. So that means we're going to be directly in between 1 and 0 and 1. So I'm going to put my axis of symmetry right there. Don't panic that it's a fraction. It's just 1/2. We can work with that. There we go. There's our axis of symmetry. Now we're going to take that 1/2, and remember we are going to evaluate the function when x equals 1/2. So f of 1/2 equals -2 times 1/2 squared plus 2 times 1/2 plus 1. So we're going to do a little fraction magic here. Remember, power first. 1/2 squared is 1/4. -2 over 1 times 1/4 plus 2 halves. 2 times 1/2 is 1, and plus 1 all the way over there on the end. So if we've got -2 over 1 times 1/4, that will simplify to 2/4, so -1/2, and then 1 plus 1 is 2. Think about it like money. You have $2, you spend 50 cents, that leaves you with 1.5. So 1/2 and then 1 and 1/2, that is our vertex. So let's plot that point. Over half, up 1 and 1/2. It's right in the middle of that particular little square. So we've plotted our vertex. The next easiest thing, and I'll remind you with orange here, is to let x be equal to 0. And that will take us to our y-intercept, which is at 0, 1. Over 0, up 1, over 0, up 1. So right away, we see that this is going to be opening down. Remember, it's going to be opening down because A is negative. Let's go ahead and use some symmetry. If we are a half unit to the left, we will also be a half unit to the right. Let's next put in 2, which will be an easy number to put in because it's even. And let's do it. I will use a little note card to help myself out here. So we are going to let x be equal to 2. So what is f of 2? Here goes. So that is -2 times 2 squared plus 2 times 2 plus 1. Remember to follow order of operations. 2 squared is 4 times -2 is -8 plus 4 plus 1, that's -4 plus 1, that is -3. So when x is equal to 2, y is equal to -3. So that's our last point that we need to plot. Over 2, down 3. Use symmetry now. Over 1 and 1/2, over 1 and 1/2. 1, 2, 3, 4, 5. We've got 5 points. Now I can draw my parabola. That's what our parabola looks like. It's opening down because A is negative. Vertex at 1/2, 1 and 1/2. Axis of symmetry at x equals 1/2. The y-intercept at 0, 1. And domain, left forever, right forever, all real numbers. The range, this time, we don't have a minimum point, we have a maximum point. And when we have a max, that means our range is going to start at -infinity and go up to that max value, which is at 1 and 1/2. Bracket. There you go. That is 1 and 2. All right, we are going to speed up the process now that hopefully everybody is following along more easily, and we are going to move a little bit faster. So, A equals 1, B equals 6, C equals -1. So to find your vertex, it's going to be the opposite of B over 2 times A. That's -6 over 2. That's -3. So the x coordinate of our vertex is at -3. That's also where our axis of symmetry is. So I'll go ahead and put in our axis of symmetry at -3. And our A value is positive, therefore this parabola will be opening up because A is positive. So let's find the y-coordinate of our vertex by plugging in the -3. So f of -3 equals -3 squared plus 6 times -3 minus 1. So -3 squared is 9, 6 times -3 is -18 minus the 1. That is -9 minus 1, that is -10. -3, -10, that's the coordinates of our vertex. Back 3, all the way down to the bottom at -10. Let's keep going. Let's plug in the 0 and get the y-intercept. When x equals 0, y equals -1. It's always the c value over 0 down 1. Next, another easy number we can plug in is -1 because we want to choose numbers close to that axis of symmetry. So let's plug in a -1. Here we go. F of -1 equals -1 squared plus 6 times -1 minus 1. That will give us 1 squared is 1, -6 minus 1, 1's cancel, that's -6. So back 1 and down 6. Now let's use symmetry in order to plot our two remaining points. 1, 2, 1, 2, 1, 2, 3, 1, 2, 3. And here is our parabola. And I didn't put in our y-intercept. There it is at 0, -1. Our domain, every single time, our domain is going to be all real numbers because this is a quadratic function. And our range, minimum value this time, minimum value. So our starting point is -10 and then up forever to positive infinity. That's number 3. One last one on number 4. Thank you for being attentive and engaged. This one looks a little bit different. Look at the function. F of x equals 2x squared minus 1. We are actually missing the x term, but we can easily put it in simply with a 0 in front of it. 2x squared plus 0x minus 1. That means A equals 2, B equals 0, and C equals -1. Let's find our vertex. Opposite of 0 is still 0 over 2 times A, which is 2 times 2. That's 0 over 4, which is 0. So our vertex has an x-coordinate of 0. That means our vertex and our y-intercept are going to be the same thing because x is 0, which makes it really easy because when x is 0, the function is equal to the c value, which is -1. So the vertex is at 0, -1. The y-intercept is at 0, -1. The axis of symmetry is at x equals 0. So let's put in that axis of symmetry, which is right on top of the y-axis. My parabola is going to open up because A is positive. So let's choose some more values here. Ooh, let's plot this one over 0, down 1. There's the vertex. So let's plug in 1. What is f of 1? F of 1 is, and you can just put it into the given function, 2 times 1 squared minus 1. Remember to follow order of operations. 1 squared is 1 times 2 is 2. 2 minus 1 is 1. Over 1, up 1. Let's plug in a 2. F of 2 is 2 times 2 squared minus 1. 2 squared is 4. 4 times 2 is 8. 8 minus 1 is 7. Over 2, up 7. And then we can use symmetry to plot the remaining points. 1, 2, 1, 2. And here is our parabola. Once again, left forever, right forever. The domain every time, all real numbers. The range, we have a minimum value at -1. So bottom to top, the range is -1 to infinity. And that is all of the notes for section 3.1.